This video is going to be on some basic geometry, specifically focusing on two-dimensional shapes and the different types of lines that you're going to be needing to know for your 5th grade standards. So I won't be reviewing everything on this poster, but the pieces that are relevant for our material. So I'm going to kind of zoom in a little closer here. So some of the first things that you need to know about are parallel lines. So parallel lines, you can see it says lines that lie on the same plane and never intersect. Basically, two lines that could run on and on forever and they would never touch. That's going to be our definition of intersecting, touching. So you can kind of see, actually, if we go next door, intersecting lines, lines that intersect at exactly one point. So again, intersecting, touching. Now in this picture, it shows the intersection happening right in the middle of the two lines, but it doesn't have to be. Anywhere two lines touch is an intersection. It's exactly why an intersection of two roads is called that, because they are touching and crossing at that one location. So parallel, never touching, intersecting, touching at one point. And then taking it one step farther would be perpendicular lines. So they are lines that intersect, but where they intersect, it forms 90-degree angles. So basically it forms perfect L's, if you will, on the four angles that are created by the intersecting lines. To be just intersecting, it doesn't have to create 90-degree angles. It can be any degree angles, but to be perpendicular, it has to create 90-degree angles. Okay, so continuing on discussing with angles, moving on to that piece. For 5th grade, one of the pieces you need to know is a right angle, which I kind of mentioned with perpendicular lines. It forms a 90-degree angle. And this little half square symbol is an indication of a right angle. So if you see that on an assignment or on a paper, it's letting you know this is a right angle. Next is obtuse. An obtuse angle is measurements between 90 and 180. So basically from 91 to 179. Because of course once you hit 90, you're at a right angle. And once you hit 180, that's called a straight angle. It's basically a straight line. So then for anything less than 90 degrees is an acute angle. So those are going to be your three angle types that you need to be aware of. For 5th grade, we do not deal with angles greater than 180, but angles greater than 180 are called reflex angles, if that is a term that you're looking to use. So the next thing I'm going to focus on are triangles. Now there are 6 types of triangles. 3 of them are referencing the lengths of the sides, and the other 3 types are referencing the angle measurements inside of the triangle. So every triangle can actually be classified in at least 2 different ways. So let me show you what I'm talking about. So first, we're going to talk about the triangle types that deal with the lengths of the sides. So if all 3 lengths of the sides are different, that's a scalene triangle. If 2 of the sides are equal in length and there's just one side different, that's isosceles. And if all 3 lengths of the triangle are the same, or equal, or congruent, that is an equilateral triangle. So equilateral, isosceles, and scalene all are terms applied to triangles based upon the lengths of their sides. So now let's talk about labels applied to triangles based upon their interior angles or their inside angles. So if you have a triangle with one 90-degree angle, and that's the most a triangle will have. You can't have more than one 90-degree angle and still be a triangle. It's literally impossible to draw that because your angles add up to 180, and that would not work to have 3 angles then. So anyway, right triangle is a triangle with one 90-degree angle. An obtuse triangle, a triangle with one obtuse angle. Again, for the same reasonings, you can only have one obtuse angle in a triangle. And then an acute triangle is a triangle where all 3 angles are acute or less than 90 degrees. So here's what I mean by triangle being able to be classified by more than one thing. So for example, this is an equilateral triangle because all three sides are equal in length. But it's also an acute triangle because all three angles are less than 90. So it's an equilateral and it is acute. Every triangle can be classified as a scalene, isosceles, or equilateral based upon the lengths of their sides, and every triangle being classified as an acute, obtuse, or right based upon the measurement of their angles inside. And the last piece I'm going to talk about are polygons. Now, the definition of a polygon is a closed figure or shape, meaning there's no open sides to it. It must have at least 3 sides, and it must have vertices or points to it. So the polygons I'm going to discuss, we have the triangle. Triangle, 3 sides. That's going to be only definition that you need to name a triangle. A rectangle. Rectangles are 4-sided, which does make it a quadrilateral. Quadrilateral is any shape that has 4 sides. And the only definition of a rectangle is it has 4 right angles. If a shape has 4 right angles, it is a rectangle. That's the only classification it needs to be a rectangle. Then we have a square. Now a square is 4 sides, so it's a quadrilateral. It has 4 right angles and 4 congruent sides. Now because it has 4 right angles, we could say that a square is also a rectangle because it has the 4 right angles, and that's the definition for a rectangle. So a square, this shape right here, can be labeled as a square and a rectangle. Okay. Then we have a parallelogram. A parallelogram is, again, 4 sides, so it's a quadrilateral, with 2 pairs of parallel sides. So that means 2 pairs. So here's one pair. The top and bottom, the top and the base, are parallel. They could go on and on forever in both directions and never intersect. And the sides are also parallel. They could go on and on forever and never intersect. So that's where the 2 pairs of parallel sides come in. These sides do not have to be, the opposite sides are going to be congruent. I kind of say to my students oftentimes a parallelogram is similar to like a rectangle that kind of just tilted over. We lose those 90-degree angles and create 2 obtuse and 2 acute. I'm actually going to hop to rhombus next. A rhombus, I compare it to almost as if a square was tilted. We don't have 4 90-degree angles. We have 2 obtuse and 2 acute. But we do have 4 sides of equal length. So that's the only definition of a rhombus. So if I come back to this is a square because it has 4 equal sides and 4 right angles. It's a rectangle because it has 4 right angles. And it's a rhombus because it has 4 congruent sides. So we can also see that many polygons can be labeled as, be classified as more than one type of polygon as well. You may have just always thought of this as a square, but it's also a rectangle. It's also a rhombus. And then we have the trapezoid. Trapezoid is also 4-sided, so it is a quadrilateral. And it just has 1 pair of parallel sides, the top and the base, or the bottom. Those are parallel. They'll go on and on forever and never intersect. But the sides, if I kept them going, they would intersect somewhere up here. So those are not parallel. So trapezoid just has 1 pair of parallel lines. So then we come on to the pentagon, 5-sided, hexagon, 6-sided, heptagon, 7-sided, octagon, 8-sided, nonagon, 9-sided, and decagon, 10-sided.